Hi everyone, welcome to the video. We are going to solve root to leaf path. In this question we are given a binary tree and we have to return all the possible paths starting from root to the leaf node. If we see example 1, we have binary tree with 3 nodes 1, 2 and 3. 1 is the root. If we start from root 1 and reach to leaf 2, then one path will be 1 and 2, whereas the other path will be 1 and 3. So there are possibly two paths starting from root to leaf. But example 2 will tell you a better picture. There are three levels and five nodes. Starting from root, traversing to the very leaf, 10, 20, 40, 10, 20, 60, 10, 30. Okay. 10, 20, 40, 10, 20, 60, 10, 30. So as you can see, it is much more like DFS. We are just traversing from top to bottom. Okay. So how will I solve this question? First of all, I'll create an empty list and create a utility function. Utility function which will have two value root obviously along with an array which is holding the value holding the current value. And what will be its parameters? Initially this array will be empty. So the base condition, if root is not there, if root is none, return come out of it. Then if we have reached the leaf node, if we have reached the leaf node, then what is the identification of a leaf node? So a leaf node will not have further a left child and a right child. Leaf will not have further a left child and a right child. So if left child is not here, if this particular node has do not has left child and it also does not have right child, if this particular node does not have left child and do not have right child as well, this means we have reached the leaf node. In this case, append this, append this element, okay, array. In the array, see, you already have array, you already have temporary array, okay, you already have temporary array, but you will have to add this roots data. This current roots data you will have to add anyways, okay, turn out of it. Then just recursively call our function once for the left subtree, once for the left subtree along with root dot data, then again for right subtree, again for right subtree along with root dot data, current root data. Now that we have passed the parameters in this function, at the end we have returned, we have formed all the paths, installed all the paths in the result. Since we'll return the result, and as you can see, it does the job pretty effortlessly. Despite being a recursive solution, it takes very less amount of time. So I hope you learned a beautiful concept and enjoyed it. Thank you. Have a nice day.